In these next few problems on the chapter review, we're going to be solving each multi-step equation, or inequality, and for the equations we need to write the property we use for each step. So number 61 says 2p plus 5 equals 7 minus 2p. So we need to choose which side to put the variables on and which side to put the terms without variables. So I'm going to put the p's on the left side and the constants on the right side. So if that's the case, this negative 2p, I've got to get rid of it from the right side and put it on the left side. So I'm going to do the opposite of negative 2p, and I'm going to add 2p. So over here they cancel, and 2 plus 2 makes 4p plus 5 equals 7. Okay, so now I need to get rid of this 5 over here on the left and put it on the right. So I'm going to do the opposite. I'm going to subtract 5 from both sides. So it cancels over there, and 4p equals 2. And so the last thing is just to get the p all by itself is to divide both sides by 4. Those 4's cancel. P equals 2/4, which really 2/4 is going to be 1/2. So my solution for number 61 is 1/2. And let's go back through and write the steps that we used. The first one's always given, and then we use the addition property of equality. So the addition, we can say POE for property of equality. And then after we use the property of equality, we always need to simplify. And then we use the subtraction property of equality. So we'll put subtraction POE, and then simplify. And then we use the division property of equality and divided everything by 4. And then the last thing was simplify in order to get our 1/2. So the solution to number 61 is P equals 1/2, and there are all of our steps. In number 62, we've got some parentheses, so let's deal with those first. So we'll distribute the 2 through both of these first two, and we'll distribute a -6 through both of the next two. So when we do that, we have 2b, and then plus 6, because 2 times 3. And then -6 times the 1 is a -6, and then it's a -6 times a -7b, and the two negatives will make a positive, so positive 42b, and that'll equal -44. So the first step was given, and the next step was the distributive property. So distributive property. Okay, so now we're going to go ahead and combine like terms. I have a +6 and a -6. I notice that those just cancel each other out. That's really nice. So my 2b and my 42b will go together to make 44b equals -44. And that step was combine like terms. Combine like terms. Now at this point, wow, we're almost done. I have the b almost by itself. I'm going to divide both sides by 44. Those cancel over here to give me 1b, so a single b. And these cancel here to give me a -1. So I use the division property of equality. Division property of equality. And then simplify. And then b equals -1 is my solution for that guy. So number 62, b equals -1. In number 63, we've got another set of parentheses that we can deal with first. So we'll distribute there and there, and we'll get 12 minus 16 in, and then the left side we'll just bring down. So now we have a variable on both sides, we have numbers on both sides, so we need to deal with those. So let's put our constants on the right, like we normally would, and then our variables on the left. So we're going to subtract 12 from both sides in order to get rid of it from over here. And these cancel. Actually, what we noticed, these cancel as well. So what we're left with is -3 in equals -16 in. So if we add 16 to both sides, 16 in, they cancel from the right, which everything cancels, giving us just a 0. And then over here on the left, they'll give us 13 in. So when we divide both sides by 13, in equals 0. Okay, so let's go ahead and write our steps down that we used. The first one we used the distributive, actually first one's given. It's always given to begin with. And the first step we actually used was the distributive property. Okay, then we use the subtraction property of equality. And then after a property of equality, we always simplify. Then we use the addition property of equality. And then we use simplify. And then we use the division property of equality. And the last one was simplify. There we go. And the solution for number 63, n equals 0. For number 64, we have the distributive property again. So we're going to distribute this 6 across this a minus 1. And when we do that, we're going to get 6a minus 6. And then our left side just comes down and doesn't change at all. It just comes along for the ride. Okay, so we need to decide which side we're going to put our a's on and which side we're going to put our constants on. So we've been putting the variables all on the left. Let's just change things up a little bit and see what it looks like if we put it on the right. So I'm going to subtract a from both sides. And I have 21 equals on that side. And 6a minus 1a is 5a. And that minus 6 is there. So in order to get rid of that 6 from the right side, I'm going to add 6 to both sides and they cancel. So my 5a is by itself on the right, and negative 21 plus 6 is negative 15. So I can divide both sides by 5, get the a by itself, and negative 15 divided by 5 will be negative 3. Then I can use my symmetric property and flip them around, so a equals negative 3. Let's go ahead and write in all of our steps here. The first one's given. Then we use the distributive property. Then we use the subtraction property of equality. We'll say POE. And then after we use a property of equality, we can simplify. And then we use the addition property of equality. And then we simplified. Then we use the division property of equality. Then we simplified. And then finally we use the symmetric. And the symmetric property of equality is what turned that guy around from negative 3 equals a to a equals negative 3. So number 64, the solution is a equals negative 3. In number 65, we see we have some fractions here. We have thirds and we have fourths. So we can either just leave the fractions alone and solve it using the fractions, or we could multiply by the common denominator. The common denominator between 3 and 4 is 12. We could multiply everything by 12, and that would then get rid of our fractions. So for this time, though, let's just go ahead and work with the fractions. And in the next example, I think we'll get rid of the fractions. So in this first one, we have our t's here and here, so 1 on each side, and then we have constants on each side. So let's just go ahead and get rid of our constants. We'll subtract 1/4 from both sides. So those 1/4 will cancel out. And on the left we have 2/3 t, and then we have 1/3 t, and then we have a negative 7 minus 1, and this will end up being negative 8 over 4, but negative 8 over 4 really reduces to a negative 2, so we'll just put minus 2 there when we simplify it. Now we can get rid of the t from the right side and put on the left by subtracting, so that cancels and that cancels. And 2/3 minus 1/3 is 1/3 t equals negative 2. Okay, so at this point we've got this 1/3 times this t, so I'm going to multiply by the reciprocal, which is 3 over 1, or really just 3. So those cancel, and t equals negative 2 times 3, which is negative 6. So my solution for 65 is negative 6. So let's look at the steps that we use to solve this. The first guy is given. Then we use the subtraction property of equality. And then we use simplify. Then we used once again the subtraction property of equality. And then we used simplify. And our solution was t equals negative 6. Actually, before we're all done with this problem, we did miss a step because we multiplied both sides by this 3. So that'll be our multiplication property of equality. And then we had our final simplify. So we just kind of had missed that for a second, but there we go. So the solution for 65 is still t equals negative 6, but we forgot to identify one of these properties of equality that we used. So there we go. For number 66, we have some fractions again, but like we said on the previous example, we can either work with the fractions or we can get rid of the fractions. In this case, I think let's get rid of them. So the common denominator here, we have a 5 and a 5, and really this 5 is over 1, and the common denominator will be 5. So I'm going to put big brackets around all this business. I'm going to put a 5 over here and a 5 over here, and I'm going to multiply everything by 5. So the 5 is going to go here to this term, this 5 is going to come here to this term, and here to this term. The reason that we don't worry about what's in the parentheses right now is because once this 3/5 gets distributed, then that 5 that we're going to multiply by the 3/5 will then be distributed. So we're only going to multiply this 5 by the 3/5, the critter on the outside here. So 5 times 3/5, well, the 5s are just going to cancel, and we're left with just 3. And the x minus 10 comes along for the ride. And this 5 and the negative 12/5, the 5s will cancel, and we'll get negative 12x. And then the 5 times the 5 will make a 25. So don't forget about this extra guy over here. Just because he's not a fraction, he still needs to be multiplied. So now we can use our distributive property. 3x minus 30 equals negative 12x plus 25. This problem looks so much nicer now since there's not fractions running amok all over the place. So we can add 12x to both sides. And those will cancel. We'll get 15x minus 30 equals 25. And we can add 30 to both sides. So those will cancel. And we get 15x equals 55. And it looks like we can divide both sides by 15. And we get x equals 55 over 15. But I know I can divide a 5 out of each one of those guys, so it'll actually end up being 11 over 3. So the solution for 66 is 11 over 3. So let's go ahead and take a second and write the steps down. The first guy was given, and then we used what we can consider the distributive property in order to get rid of those fractions. Then once we did that, it was interesting, then we actually did the distributive property on our parentheses. So we actually did the distributive property twice in a row, once to get rid of the fractions and once to get rid of the parentheses. So then we use the addition property of equality, and then we use simplify. Then we use the addition property of equality again, and then we have simplify, and then we used our division property of equality, and then simplify. So it's hard to see all that at once on the screen, but the solution for 66 is going to be 11 over 3. In problems 67 through 70, it says to solve and graph each multi-step inequality. So this shouldn't be so bad. So we've got a negative 3m plus 5 is greater than 6m minus 4. So let's get our m's on one side and our constants on the other. So we'll subtract 6m from both sides. When we do that, those will cancel, and this will be negative 9m plus 5 is greater than negative 4. And then we can subtract 5 to go ahead and get rid of that and get our m by itself. And then we have negative 4 and negative 5 makes negative 9. Okay, so to get the m all by itself here, we're going to divide both sides by negative 9. So the negative 9 and the negative 9 cancel. This negative 9 and negative 9 cancel. And we're left with m and a 1. But you must remember that when we multiply or divide an inequality by a negative, like we did here, we have to flip the sign of the inequality. So instead of being greater than, it's now less than. So our solution is m is less than 1, and then it asked us to graph it. So we have 1 in the middle, and we always go 1 to the right and 1 to the left. So 0, 1, 2 will be our number line that we see. And it's going to be open at 1, and since it's less than, our line is going to go over here to the left where it's less than, toward the negatives. And I'll shade all that in. So the solution for 67 will be m is less than 1. So we have an open circle at 1 with a line extending indefinitely to the left. In number 68, we have a negative x minus 24 is less than 6 times the quantity x minus 4. So we need to distribute that 6 through both of those. So it'll be negative x minus 24 is less than 6x minus 24. Okay, so let's go ahead and add 24 to both sides, and we'll notice something nice, that these cancel, but hey, those cancel too. So I've got negative x is less than 6x, but we need to get our variables together, so we're going to say negative 6x on both sides. We'll subtract the 6x. So we have negative 7x is less than 0. But in order to go ahead and complete this, we're going to need the x all by itself. So we're going to divide by negative 7 and x, and we have a 0 on the right side. But again, we divided by a negative, so we've got to flip that sign around. So in this case, it's x is greater than 0. So when we draw a number line, we'll put 0 right there in the middle. And we'll go 1 to the right and 1 to the left. So we open circle at 0, and since it's greater, we're going to head over here to the right. So the solution for 68 is x is greater than 0, and it'll be an open circle at 0 with a line extending indefinitely to the right. For number 69, we notice this inequality is a not equal to. We've got some parentheses, so let's go ahead and distribute. We'll actually have to distribute twice, once with a positive 5 and once with a negative 7. So when we do this, we'll get a 5y minus 30, and then a negative 42, because of negative 7 times 6. And then be careful, it's a negative 7 times a negative y, so it'll be plus 7y is not equal to 24. Let's go ahead and combine like terms. So we have on this left side, we got a 5y and a 7y, so 5 and 7 will make 12y. Then we have a negative 30 and a negative 42 will make negative 72, and that is not equal to 24. So when we add 72 to both sides, they'll cancel over here. So we have 12y is not equal to, it looks like 96. So we'll divide both sides by 12. Our 12s will cancel, and y is not equal to 96 divided by 12 is going to be 8. So when we graph this rascal, we'll have 8 in the middle because that's the value we care about. And we'll always go 1 to the right and 1 to the left. So it's an open circle at 8 since it's not equal to 8. And recall that if it's not equal to 8, it could be anything else. So we're going to shade everything else on this number line. So there we go. So the solution for number 69 is going to be y is not equal to 8, and it's going to be an open circle at 8 with lines extending indefinitely in both directions. The final problem on this set of 10 is going to be number 70. We've got some fractions in here with this inequality. So kind of similarly to what I did on a previous problem in this set of 10, I'm going to make these big brackets. I'm going to find the common denominator, and I'm going to distribute that common denominator through all these terms, thus getting rid of all the fractions. So 4 and 2, and this 4 over 1. So the common denominator looks like 4, so I'm going to multiply everything by 4. So this 4 will go here to the 3/4, and this 4 will go here to the 4, and then here to the 1/2. And for the same reasoning as last time we discussed, so once this 4 goes to the 3/4, then it gets distributed. So those terms will have to wait a second before it gets this 4. So we will not multiply this 4 by every single thing we see, only by this set once, because then once it gets distributed, that'll take care of it. So 4 times 3/4, the 4's cancel, we get a 3. And then we have 6 plus 3x greater than or equal to. And then 4 times a half, or we could say half of 4, is 2 with the x plus 3. And then 4 times 4 is going to be our minus 16 right there. So in this case, now we can actually go ahead and distribute these guys. So we have 18 plus 9x greater than or equal to 2x plus 6 minus 16. So we got some like terms over here we can put together. So 18 plus 9x greater than or equal to 2x minus 10. So let's go ahead and get all of our variables on the left side. So I have 18 plus 7x greater than or equal to negative 10. Okay, and then let's subtract 18 from both sides. So those will cancel. And we get a 7x is greater than or equal to, and then negative 10 and negative 28, or I'm sorry, negative 10 and negative 18 will make a negative 28. And then we can divide everything by the 7 right there. Kind of keep moving everything up. So the 7's cancel. I get x is greater than or equal to negative 4. So that's my solution. But then I have to graph this solution. So the negative 4 goes in the middle. That's what I care about. And I go 1 to the right, 1 to the left. It's going to be a closed circle at negative 4 since we had that equals there. And then since it's greater, it's going to go over here toward the greater side. So the solution for number 70, the final problem in this set, is going to be x is greater than or equal to negative 4. It'll be a closed circle at negative 4 with a line extending indefinitely to the right.